Not totally sure what I'm going to talk about in this video. Um, because, to be honest, I'm kind of in a rush. And I haven't had the time to prepare. So I'm going today with my girlfriend to hiking at a state park. And I need a video for today. And I'm not super confident I'm going to have the time to come home and edit a video. Or, well, film and edit a video. So here I am, just real quick, squeezing a little bit of something before we could... before we leave for the state park. And usually I'm a day ahead. So like, yeah, because technically I'm not a day ahead right now. Usually I'm a day ahead. Like normally what I filmed yesterday I could upload today. But Thursday night I lost that streak because I had one of the most crushing, debilitating headaches I've had, I think, in my entire life. And I've had bad headaches. I had epilepsy when I was a kid, so like I think that is a big cause of my headaches later on in life. And so I'm you know, no rookie to a good fucking head pounder, and holy fuck. Thursday night it was like debilitating. So I didn't film anything. I just laid in my dark room because I couldn't even like a light was destroying me so bad. I hate that. It's so frustrating. But there's not really anything you can do about it, right? Go with the punches. Move this down a little bit. But today should be exciting. I am going to film today. It's a beautiful state park. It's called Letchworth State Park. So we're going to go to the grocery store and get some snacks and such. And then go on a hike for a couple of hours. And then chill in the car and eat some snacks and come back home. And then go see the niece tonight, I believe. But I do want to show you something cool. I don't think I've showed you guys this. This book came in. The Handy Quantum Physics Answer Book. This thing, have I told you guys about this? I don't think so. So literally, it's any like question you have about quantum physics, the answer's in this thing. So like, look at the table of contents. So like, I'll go. Let's see. Where do we want to go? So we want to see what the wave function is. So I'll go to page 154. I'm like obsessed with this thing. Because you can just skim through it and learn so much shit. They have the Schrodinger's equation in here. They have it's everything quantum you want to know. But what are we trying to look up? I think it's page 154. Wave function. So like, dude, look, it literally shows you. Question and answers. It's straight to the point. There's no bullshit. It's just straight to the point. What is a quantum wave function? A wave function describes the location of a quantum particle at any given time of the particle's existence. The location is not a single point in space. However, it is represented as the sum of a real number and an imaginary number, which means there can be an unknown or an uncertain component of where that particle actually is. It's sick. This is so sick. I was totally dirting out on it for like an hour when it came in. But let's see if there's another question that's... In quantum physics, what is an observable? Quantum physics is different from classical physics in that the act of measuring a property in a quantum system actually causes that property to take on a set value. Rather than take a ruler or a thermometer to a quantum object, physicists need instead to characterize observables with more abstract mathematical descriptions. If you represent a quantum system as a mathematical... Oh, computer, I think my computer just went dark. Where was I? If you represent a quantum system as a mathematical construction of many quantum states, then an observable can be represented by another mathematical construction called a self-adjoint operator. When the observable interacts with the quantum system, you can use a linear algebraic techniques to calculate a number that represents the value of that observable. Just got all these. It's straight to the point. Questions and answers. Let's see. There's another cool one when I flip through. Not on a phone. Oh, here's a cool one. Antimatter. What is antimatter? Antimatter is made up of particles that are reserved in several important properties compared to ordinary matter. For example, an antiproton would have the same mass as a proton but have a negative electrical charge rather than positive. The German-born British physicist Arthur Schuster, 1851 to 1934, coined the term antimatter in 1898, hypothesizing the existence of antiatoms and even antisolar systems. But he had no mathematical or experimental basis for his ideas. With the advent of quantum physics, the English physicist Paul Dirac, I think is how you say his last name, Dirac, laid a theoretical basis for the idea of antimatter starting in 1928, suggesting the existence of antiparticles. That's all I got for today. Figured I'd show you my cool little book, but it is time to go to the state park. So I will talk to you guys tomorrow. Peace.